Moving on to the physical properties of non-metals. The important physical properties of non-metals are, starting with their brittle nature. Non-metals are brittle in nature. Brittle means they break easily. So when we say non-metals are brittle, this means that they can break easily. Next chemical property is ductility. Ductility refers to the property of a substance to be stretched into wires. So non-metals are non-ductile. That is, we cannot draw wires out of non-metals. And if we compare this property of non-metals with metals, metals are ductile while non-metals are non-ductile. The next property of non-metals is malleability. Malleability refers to the property of a substance to be beaten into thin sheets without breaking. As far as non-metals are concerned, non-metals are non-malleable. That is, they cannot be beaten into sheets. Again, we can compare this property of non-metals with that of metals, as metals are malleable. Moving on to the next property is conductivity. Here we refer to thermal and electrical conductivity of non-metals. As far as non-metals are concerned, non-metals are non-conductors of heat and electricity. So non-metals do not conduct heat or electricity. However, there is an exception here which should be noted. The exception is graphite, which is an allotropic form of carbon. Graphite is a good conductor of electricity. So there's a non-metal graphite which is a good conductor of electricity, while all other non-metals are poor conductors of electricity. Moving on to the next property, that is luster. Non-metals are non-lustrous. This means that they do not shine and they cannot be polished. However, again, there's an exception here, that is graphite. Graphite is a non-metal which is lustrous. Also iodine. Both graphite and iodine are lustrous. Next physical property of non-metals is their physical state. Non-metals are found in all the three states, that is, non-metals are solids, liquids, as well as gases. So they are found in all the three states. For example, carbon is a non-metal which is found in solid state. Bromine is a non-metal which is found in liquid state. In fact, bromine is the only non-metal which is found in liquid state. And nitrogen, oxygen, etc. are gaseous in nature. Next physical property of non-metals is their hardness. Non-metals are generally soft. However, again there is an exception in this property, which is very well known exception, that is diamond. Diamond is also an allotrope of carbon, and in fact it is the hardest natural substance known. Another physical property of nonmetals is their melting and boiling points. Nonmetals have low melting and boiling points. However, again there's an exception to this property. Graphite, which is an allotropic form of carbon, has a melting point of about 3700 degree centigrade, which is very high value. Next physical property of nonmetals is their density. Nonmetals have low densities, but iodine has a density about 4.94 gram per centimeter cube, which is high as compared to the densities of other nonmetals. Moving on to the chemical properties of metals. We had seen the physical properties of metals earlier. Now we are referring to the chemical properties of metals. Before we start the chemical properties of metals, we should know the electronic configuration of metals. The general electronic configuration of metals is that the atoms of metals have either 1 or 2 or 3 electrons in their outermost shell, due to which they have a tendency to lose electrons and form positive ions. So according to the electronic configuration of metals, they have 1, 2 or 3 electrons in their outermost shells, which are loosely held by their nuclei, and so metal atoms can easily lose their electrons to form positively charged ions. For example, sodium, whose atomic number is 11 and its electronic configuration is 281. So it has one valence electron, that is one electron in its outermost shell, and in order to gain stability, sodium loses an electron and forms Na+, whose configuration is 2,8. Another example we can take is magnesium, whose atomic number is 12. Its configuration is 282, so it has 2 electrons in its outermost shell. Again, magnesium, in order to gain stability, loses 2 electrons and forms Mg2+, whose configuration becomes 2,8. Similarly, aluminium, whose configuration is 2,8,3, it has 3 valence electrons, and to gain stability, it loses 3 electrons to form Al3+.